Alright, so I'm coming at you with a bit of an update for the R² progressive steering trucks. And today we're looking at Mark's truck. So Mark's been working behind the scenes and he's been writing and making a bunch of revisions, and he's starting to get like really serious about it. And I'm trying to get my hands on the latest prototypes from him, but I've been thinking about them quite a bit lately. And one night I woke up and I had this thought about how these trucks are actually working, and that maybe it's not actually got progressive R² steering. So for an overview, what we got going on is we got this back here is the bushing anchor, and as the truck leans, it's going on these tube bolts. And because it's going on the tube bolts, as it rotates on this one, everything kind of goes up, and the center of gravity raises, and yeah, it goes up. And the idea is that as the center of gravity raises, so does the pivot axis. And so as you turn, the angle increases. And that made sense. I think that makes sense as an explanation. But then I was thinking, but wait, where are the 2 points that it's actually pivoting at? Because if you want an axis, you have, you have a pivot point here, which is the anchor, and you've got a pivot points here and here. So these pivot points start at this height, but as you pivot over here, there's not actually a pivot point that's going up. The pivot point is actually this other, one of the 2 bolts, which is staying at the same height. So I thought it was important that we get a tangible answer to what's actually happening. It's easy to make things based on your presumptions, but I mean, and we were kind of presuming that it had R², and now I don't want to be looking at this and it presume it doesn't. I need to find the answer. So I actually made this at the very start of Mark's, well, I've been wanting to make this for a long time, and I actually made it at the start of Mark's project. What this is a spring-loaded pen, and it's a plotter that threads on to an axle. And I'll be able to thread it onto an axle, and I'll be able to draw out what the axle path actually is. So let's go ahead and do that now. All right, so to start off with, I'm just going to set up this plotter thing with a Roja truck. So a Roja truck is operating on a fixed pivot, and it should just draw a perfectly straight line and almost like project a plane that it's sitting on. So take the cap off, put the block back, and let's draw the line. Right? It's a perfectly straight line because it's a perfect precision truck that's articulating on bearings. Can't get more precise than that. Perfectly straight line. And if I was to, say, try to deviate and try to influence the hanger, so if I try to torque the hanger and twist it like this way, I can't get it. I'm able to move the table and the base plate and the block of wood. So it's perfectly precise. Oops. Don't want to break my nub there. Okay. Perfectly straight line. So let's plot out. Oh. Let's plot out this trucks. Might need to start closer. that is most definitely not a straight line like this is. All right, so I do want to check one other thing. I do want to check how much slop there is at the top of the travel. So the top of the travel was about here. I'll do that slop test over here. So it's part of it in graph. So this is where it wants to naturally travel. I'll do it up in this direction. And if I try to torque the hanger, I can get it to torque quite a lot this way, and I can get it torque a bit less. So I can get some side-to-side motion out of it. And if I'll show you, so that's due to the way that this bushing here is able to flex and deflect out of the way, and it's even able to pull this wing open a little bit, and that's able to do all that to the turning. So now that we've established some measurements, let's take a look at what that means. Let's dissect this a little bit. So let's look at the work of the Roja first and get kind of a baseline. So the pivot axis is going to be perpendicular to the plane of the axial travel. So this would be the pivot axis of the truck, would be this line. The more turning you're getting and the higher the pivot axis is, the more horizontal the movement is going to be. So if it's a very flat line, then there's going to be a lot more turning. It's a higher angle truck. And if it's a very vertical line, it's a lower angle truck. So that's what we've got here with this much higher angle. It's in fact a lower angle truck because the pivot angle is perpendicular. So let's try and get an idea of what this pivot angle is at the start and at the end. Just kind of eyeball this angle here as roughly that. So it seems to be close to about 14 degrees. It's supposed to be a 15-degree truck, I think. So that's pretty good. So what the angle is at the very end actually doesn't really matter. Whatever this angle is, isn't really what we're interested in. What we're interested in is the angle from this point to this point. So let me get another color pen real fast. It's going to be about that angle there. So what's that angle? I'm measuring that angle to be 22.5. So essentially, if you lean far enough to where you're getting this full extent, which admittedly is leaning a lot, instead of having the turning radius of a 14-degree base plate, you're going to be having the turning radius of a 22.5-degree base plate, which is actually a pretty significant difference. So, and if we look at the difference between the Sharpie line and the black pen line across any point, let's do my blue pen. So the R squared is basically filling up this volume and this volume, and that's its contribution. You can see as it grows as you lean more. Really cool. Let's take a look at what's really going on and where I was misunderstanding things. But first, I would like to point out one thing. I did measure what the pivot angle is on this truck. It's actually 10 degrees. So I've gone ahead and expanded my chart here, and the overwhelming majority of the turning that is happening on these trucks is actually going to be through this secondary turning mechanism, not through the pivot axis. So now that we got that out of the way, what is this mechanism? How's it working? I built this model here to represent same thing here. It's got these two posts that are going to act like the two bolts, and I've got a spherical joint to act as the pivot anchor. So basically, if we look at this, and we can see it rolls up this way and rolls that way, and it's doing the same thing. So we put a rod here, and we rotate the hanger right there along that point. You can see the rod is basically just spinning, as long as I keep it lined up right. And that's because for this motion, that is the pivot axis. It's pivoting here along this axis, and it's pivoting here along this axis. So you can imagine the two-bolt system as actually being a two pivot axis system. And the axes of these pivots don't go up and down. We're visualizing, so as this turns, this angle goes up. So we're visualizing that as an increase of the pivot angle. That's not what's happening. The pivot angles are here, and they do not raise, they stay at this same level. If that's not where this extra steering is coming from, where is it coming from? So there was one other thing that I was misunderstanding as well. So if you look at the width of the posts here, as you roll the hanger onto this side, if we just talked about the vertical up and down motion, I was also envisioning a side-to-side motion. And you can see the center of this hanger does move to the left, and this rod points to the left when I move to the left, and it points to the right when I move to the right. So I was visualizing it sort of like going like this, right? So it would head towards this post, or this one of the two bolts, or it would head towards that one. And that was a problem because that motion is actually counter to the direction you want the hanger to travel. So this would be motion taking away from the turn. But of course, the hanger isn't doing something like this, where it's twisting in the wrong direction to get to this point. It's actually kind of more going like this, and pivoting like that, and staying in plane. So really the way to visualize what's going on is to look at a system like this, where we roll it on this axis, and then we roll it on this axis. And you can see, and if I raise the camera, if I hold the rod I'm spinning on the same plane as the camera, and I twist this, if we just look at the line of the axle on the 2D plane of the screen, you know, if it's going like that, it's turning right. If it's going like that, it's turning left. So I twist this, it's going left. If I twist this, it's going right. So it's the opposite of what I was thinking. And this is actually where the turning action is coming from, is as it twists on this axis and as it twists on this axis. So how it works is on all the trucks, the pivot axis is perpendicular to the axle. And on this truck, the pivot axis is not perpendicular to the axle. That's why it's got the R squared. Not because of a raising hanger, but because we have two pivot axes that are not perpendicular to the axle. So I'm still working on wrapping my head around that myself. So if you find that explanation a little bit lacking and just kind of like hand-wavy magic, That's why. But I am very, very confident now that that is the mechanism which is causing this, this behavior. These angles here versus this angle here. There we go. The investigation into the R-squared mechanism of this truck, I guess, is over for now. And we'll see if I gain additional insights later, but as of this moment, Longboard technology, over and out. Alright, so quick addendum. I was uploading the video footage to the computer and it just all clicked. It's just all completely clicked now. So, here's what's going on. So, whatever angle this is, for this pivot axis here, when you rotate that pivot axis 90 degrees, that becomes the angle that the truck is turning at in the opposite direction of that axis, right? So you lean this 90 degrees. Because that angle is 45 degrees, it's now turning 45 degrees, right? So this is actually the exact same mechanism that trucks are already working at. See, look at this. So here we go. Here's the Roja. Here is the pivot axis. And as you rotate the pivot axis, or on the pivot axis, look at that. It's a 45 degree pivot axis, and now it's doing a 45 degree turn. And we take it back, and now it's doing a 0 degree turn. So it's the exact same mechanism that is already applying to skateboard trucks, but instead of it happening on this plane, it's also happening on this plane. So we're just taking advantage of more planes with the same mechanics. And that's what's making the R-squared. And I am so excited now that I figured that out. That makes so much more sense. And it's really cool. So now, for real, Longboard technology, over and out.